Good morning, everyone. Thank you for attending our presentation. My name is Pavel Marek. I'm a compiler engineer at ENSO. This is Jaroslav Tulach.
And I'm also a compiler engineer at ENSO.
Most famously known for being the architect and the original designer of the NetBeans platform.
Okay, thank you.
Our presentation has a little bit cryptic title. There is module path beyond class path. And I would like to start with a quick poll. So raise your hands if you have ever used module path and if you have a vague understanding of what a Java module is. Okay. We see a few hands. This is something what we would...
Well, up to 10 people.
Up to 10 people, okay. That's pretty nice. You can ask your questions during the presentation. We will try to answer them during the presentation because we are two, so we can do that. Okay, back to the title. So basically, the whole presentation is about our journey towards modularization and why we had to do that. A little bit disclaimer. There is this GraalVM and Truffle, which are technologies that we use. These are our dependencies. And in one of the recent versions of Truffle, the Truffle started requiring your application to be provided as a Java module. So we were kind of forced to migrate basically our jar archives towards the modules.
Sorry for interrupting. I would say some of you who tried the module path might do it for fun. We were forced to do it, so we had to. And that's what we are going to discuss, talk about today.
Most probably, if we were not kind of forced to do it because of the dependencies, we would not do it because everything was working before that. And so we are going to share a few pain points that we struggled with, along with maybe some benefits of the module system. Okay, so let's first start with a little bit of an introduction of what ENSO is. Jaroslav, would you please?
This is a kind of shameless plug, but we have to do it because otherwise our company would not let us speak here. And at the end, it should be a nice demo. So this is the IDE that we are developing for the ENSO programming language. And the ENSO programming language is a language that allows you to do visual and textual development and do both at once. So this is the visual part. When you create a new project, it basically starts with a single node that contains a value, a string value. So now, the idea is basically to do no-code development, to develop with a mouse. So what I can do, I can drag down from this node, and immediately I see all the operations I can do with a string. One of them is split. So I'll say, okay, let's do split. And I get a new node, and I can inspect its value. I can check how the value looks like. Well, of course, it is showing an array with one element, because we have not specified the delimiter. So let's do it. We will split on spaces, and we immediately see that now we have an array with much more elements. How to move forward? So let's imagine we want to process these words somehow. So the easiest way is to select one of the elements. We get another node. And that node is again representing a string. And with string, we can, for example, say we want to convert it to uppercase. So toCase is the method to call. And case option basically tells us, gives us a chance to select whether we want lowercase or uppercase. So now we have uppercase. And that's not all. Another operation that we might want to do is to reverse the text, for example. So let's reverse it. We see the preview, and when we select it, we get a note that shows the result. So this is basically the visual part of the Enzo programming environment. But what I can do, I can also open the textual part. So while I was dragging here the nodes, a code in Enzo language has been generated for me. And it's a simple code of like assignment equals some function call, something pseudo object-oriented. But what I can do, I can, for example, go here, and in the code, change 2 to 3, and I immediately see that the value in this last node has changed. And I can continue. Okay. So 5, and again, I see the changes. So this is a kind of interactive live programming environment. The last thing that I'd like to demonstrate is that it's really not just dragging nodes, but you can also define a function and coroutines and use them in an anger. So I can select these two nodes and tell the IDE to generate a method or function from it. So now the result is the same, but we have a function called collapse, and we can use it. So what I'm going to do here is I will apply this function to all elements in the vector that I have. So right now, we can compare the result. Yes, we can compare the results. So here is the array of array with elements that we got from splitting the text sentence. And here is the applied modifications. So this is basically how the Enzo programming language works. Let me go back to slides. Do we have any questions? No, not yet.
Not yet.
Well, in case you want to know something more about the Enzo programming language, here is a summary, but you can also ask. So, dual representation. I do remember when I was working on NetBeans that actually generating some Java code, letting the user edit the code, and then understanding what are the user edits has been really hard. Basically, the only way to do that is to execute the code. But that's not what you want, because executing code in the IDE is kind of dangerous. For example, if you have a Java bean that calls system exit, the IDE exits unless you do some special tricks. So executing is not the right way to do it. But Enzo is really designed in a way that there is one-to-one mapping between the visual and textual representation. So this kind of going back and forth from the visual and textual representation is way easier. One thing to mention is that Enzo is basically a functional language, so all the variables are immutable. And the reason for that is that the IDE is constantly re-executing everything that has changed, and we want to avoid side effects. So functional language is a great fit there. Last but not least, Enzo has a strong interop story, strong interoperability with Java and with other languages built on top of Java virtual machine, like GraalPy is an fast implementation of Python, or GraalJS is a Node.js compatible implementation of JavaScript. And we can basically mix and match objects coming from all those languages together. And this mix and matching is a result of using a framework called Truffle. Truffle is being developed by Oracle Labs, and they develop GraalVM as well as Truffle, Graal compiler. It's a whole ecosystem. And recently, what they did last summer, they released Truffle Unchained, which means that all these truffle-based languages like JavaScript, Python, are available as jar files, and you can download them from Maven and put them into your application. And that application can run on any JDK 21+. You don't need any special JDK. Only if you want full speed, you should also run them on GraalVM. But yeah, basically the Truffle Unchained is a huge step forward for the Truffle and its languages, because now you can really take the jar files, like any regular jar files, and use them in your application. So if you want JavaScript, Ruby, R, programming language, or Enzo, just take it from Maven Central and use it. There is just a single drawback. The languages, or the Truffle team decided that a language must be implemented as a module. That's new. Up until last summer, you could just implement your language as a regular Java application with a normal jar file, and everything was working. But not since last summer. And we had to upgrade to that new version, and we needed to turn Enzo into a Java module. And Pavel did all the work, and he's here to give you a sense of his suffering. So first of all, Pavel, what is the difference between jar file and Java module?
Well, basically the only difference is that the Java module is just a normal jar file, but it has this kind of module info compiled in its root. As you can see, this is an example of the module info.java. It is kind of a special syntax. It's not really Java. It was introduced in Java 9. And let's just go through some very basics of this. By the way, it is also called a module declaration. So obviously, we can have a name. The name usually follows the same naming conventions as the packages, which is the reverse domain name. We can have optional modifiers. Here we have an open, which means that the module will be opened to introspection at runtime, which is, by the way, not a very good idea to declare it this way, because it means that it will be opened for a reflection from all the other modules that you have in your application, which is not a good idea. You want to restrict it. And you can, for example, restrict it by saying that you want to open just one specific package to another module.
Well, basically, modules are a way to increase encapsulation and safety when programming in JDK and when using JDK or programming your application and using modules. So opening up too much is basically a recipe for being hacked. So that's the reason why opening is not completely a good idea.
Exactly. One other perception of a module is that it is like one level above package. So module is just a set of packages. And you can say that some of these packages are like private to your module. So no other module can access these packages.
Maybe you faced such situation that you have a jar file with many packages and you want just a logical part of that system to be visible outside and the rest be encapsulated. So modules are exactly here to give you that kind of encapsulation.
Okay, let's go to another declaration. The requires keyword tells the module system that what kind of dependencies you have. So you can name another module that you depend on with this way. By the way, you can use the static modifier like so, which means that the org slf4j module will only be required during compilation and not during runtime. So if you don't have this module at runtime, the JVM will normally work. But all the other modules that you require need to be on the module path at runtime. Otherwise, the JVM will fail to boot. Terminology note, it is said that a module reads another module, and it's just a dependency of another module. This, you can export packages. You can either export the whole package. You don't like this part of to something is optional part. You can only export the package to all the modules, or you can export it to just one particular module. So in this example, we export the package called org and the runtime to a module named org and the utils, which means that at runtime, only this org and the utils will be able to call classes and methods from org and the runtime module. Another thing that is quite new in the Java ecosystem, or at least it was new when the modules were introduced, is the declaration of service consumptions. So in your module info, you can declare that you use some services, and this basically enables the JVM to check that at runtime, when you are calling the service loader.load method, you are calling it with one of the classes that you are specifying in this uses declarations. So you can only use the services that you specify with this uses keyword, which is, well, something that is pretty useful. Then you can provide some services. The syntax is this. You say that you provide some service, class name of the service. And these are the providers that you specify. So these are the classes that implement the service interface. This will be checked at compile time, that you actually have these classes that implement the service, and that these classes actually implement the service.
So I wanted to note that one part of module systems of any module system is to help you manage dependencies between your components. So that's the requires and exports part. However, another really important thing is service discovery and registration, and that's the uses and provides thing. So here we are basically mixing two concepts, but both of these concepts are quite important. The services are basically a way, if you are familiar with dependency injection, so this is basically the way to do dependency injection between modules in the JDK module system.
Okay, Jaroslav, tell us something more about the history of the Java and modularity, because before the Java platform module system, there already was some attempts to modularize Java, and Jaroslav has a very rich experience in that.
Yeah, probably because I wrote one of the module systems called the NetBeans Runtime Container. The other, and we did it in the year 2000, so it's not completely new thing. The other system, which was not only written but also well specified, is called OSGI. Anyone knows what OSGI is? Okay, that's good. Who hates OSGI? Yeah, the same people. Perfect. Yeah. No, okay. So, no, not all of them. But yeah, so basically what happened in 2005 is the JDK team decided that they want to implement a module system. And at that moment, IBM guys stand up and said, well, use OSGI, it's perfect. And yeah, basically what the JDK team needed to do is to come up with something different. So JDK, or the Java module system, is slightly different. It is simplified in certain ways, because one of the claims about OSGI was that it's too complicated. Well, at the end, if you want real runtime container, it has to be slightly complicated because it needs to be useful. But yeah, the truth is that simple things should be easy, complex things should be complex. And in case of OSGI and also probably the NetBeans solution, even some simple things were complicated. That's for sure. But on the other hand, if you ever try to do microservices, where you distribute the microservices independently, you run various versions of the same microservice at the same time, you know that's complex. And basically with modularity, you get something like that. Just modularity gives you a way to do all these deployments and dependencies inside of a single process. So it's microservices for a single JVM, let's say. But yeah, so basically Java module system was slightly late, had to be slightly different. One way to differentiate was the introduction of the module info, which gets compiled. But we have it. And slowly we are forced to use it. And OK, let's move to the next slide. And oh, we have questions. We have questions. So let's try to answer them. So first question is actually relates to my to my demo of Enzo language. Enzo, oh, can you switch to the questions?
Oh, sorry. Yes.
Yeah. Enzo, can you define better variable names when programming visually? The topic of this conference and the topic that everybody talks about is AI, artificial intelligence. So I believe the best thing what we can do is to use AI to give us better variable names. Well, I'm kidding, of course. But no, it's not that bad idea, but probably we will fix it. We just, and we are discussing how. And I did propose use of AI. So we understand it's a problem and it's going to be fixed. Do you know why decision to move to modules was made at Truffle? Yes, I do. Because of the poor adoption. So basically, if you ever heard about those Truffle ecosystem with the Graal.js language or Graal Python language or Graal Ruby or Graal FastR, developed originally by Pavel, you might always associate that with GraalVM. And it was a blocker for adoption because many people don't want to switch JDK. They have their own JDK and then they want to use it. So the Truffle Unchained was basically a way to really unchain the Truffle and make it usable on every JDK. And why they are actually using modules? Because of encapsulation. So if you have an implementation of the language, then if there is an implementation of a language, you just put it on class path of your application, and it gets activated. And you can use it through so-called Truffle polyglot APIs. But the intention is that people always use only those Truffle polyglot APIs. They never call directly into the JavaScript implementation or into the Graal implementation. And to hide the implementation classes away from the regular developers to not make such a mistake, they decided to use modules and basically hide all the packages. So if you talk to these languages, like Graal.js or Python, you do it through the polyglot API, and the API itself then talks to the modules. But you, as a user, use a single unified API to access all the languages. So that's the reason.
By the way, an important thing to note here is that we are not only talking about the compile time encapsulation, that you cannot use some, call some other methods from other packages from other module. But an important thing is that there is a runtime encapsulation that is basically for free when you are using modules. So when one module does not export a package, it means that you cannot load the classes from that module in any way. So if you would have just everything on the class path, like the old style way, you could load the classes basically from anywhere, as long as you would know the binary name. But with the modules, there is this strict encapsulation that you just cannot access the classes from different module in any way. It is just closed, and it is built into the JVM, so this was also one of the motivations. And since it is already in the JVM, you don't need to reinvent the wheel, so that was the decision.
Yeah, that's correct. There is no overhead. And
yes.
Even there are encapsulation benefits and maybe even performance benefits. How do Java modules relate to Gradle modules? Gradle or Maven modules are compilation unit, I would say. So if you have a compilation unit, then a compilation unit can contain module info, and it will turn into a Java module if your tooling is good enough. I know Maven tooling is good enough, and I assume Gradle is as well. So the only difference is to put that the module info, and then maybe configure it a little bit, but things basically should work, and you can turn your jar file into a module jar file. Where handler factory was declared, that's a question about your slides.
Handler factory, okay. The handler factory is this one. And the question was, where was declared in requires part? I'm not sure I fully understand the question. So, oh yes, so this handler factory is a class that I believe is implemented in either in some different module or in this module. It does not really matter, because this is just the name of the class that you, the name of the service that you use, and it can either be in one of the modules that are your dependencies or inside your own module.
Well, it's a tricky question.
It's a bit tricky question. Let's see the example first, and let's skip the question for now. Because...
Well, can you return back?
Sorry, yes.
So there is a chance for another quiz. So who packages your application as a fat jar? All the classes into a single jar file. A lot, yeah. We did the same thing in Enzo as well. All the libraries were put into runtime.jar, including our code, and we had to fix it. So Pavel, your turn. Now just tell us.
Okay, let's see some code, because without code we cannot really see how that works. This is the minimal example of an application, so that we can see some of the problems when you are trying to convert the fat jar to modules. Let's have 5 modules. In lib, there is a service interface. We will have 2 service providers, the add provider and the sub provider. And then a utils module that will have the same package as the lib module, and a class that accesses some package-protected stuff from lib. And then it is a runner that just uses everything. Let's see the code now. So we have this is just a bunch of Maven projects, by the way, as simple as it gets. The lib project has a service declaration, the service interface, with just a single method, that combines 2 integers. The lib class uses a dependency injection pattern. So into the constructor, you put the service provider, and it then uses it to call the combine method. Then the service provider discovery. So we load all the service providers via the service loader load. We just wrap it in the lib and return it as a list. And there is just some package private stuff that is called from utils. Note that the org and zolib and org and zolib, these are the same packages, but they are contained in different modules. Service provider has just one class, This one combines the integers by summing them, and the sub-provider is exactly the same, but it combines them by
Subtracting.
yes, subtraction.
Yeah.
And
They are registered providers of the service interface that can then be discovered in
Yes.
the library.
The runner, it just it calls the utils, prints the result from it, and then it loads all the providers. The lib all loads, discovers all the services, and loads it, and calls the combine on it and prints it. Okay, let's build the fed jar. Now we have a fed jar in runner target. This is our fed jar. Let's see the contents. So first of all, in the manifest, we can see there is a main class. We will run it as a Java jar, so we need that. Inside the services, we can see that we have two service providers bundled in the jar. Okay.
So probably, sorry for interrupting, the service loader API has been in JDK since JDK 5 or 6, maybe, 1.6. And so it's there for a long time. But with the invention of modules, the API has been modified to do different way of discovery and registration. Originally, the registration was done by this special meta in services file. So this example is not modular. This is using the old JDK approach.
Yeah, exactly. And we can also see that there are all the classes from our application. So we can see lib, utils, both the providers, and everything from the runner. Let's try to run it by Java jar and just the one jar file. And we can see that it does what we would expect. It discovers two service providers. We have two service providers in the fed jar. And it calls the utils, the method from the utils. Easy as it can get.
Yeah, it's
Okay.
easy, but it's a fed jar.
It's a fed jar.
We
Okay.
don't want fed jars.
Let's modularize.
Good.
Okay.
How do you modularize?
The first thing that we are going to do is that we are going to check out a different branch, clean everything, okay.
So this is how people modularize. You do git checkout.
We just, so that we can see. What we will do is that we are going to add the module info files inside every module. This is the simplest thing that we can do. And so, for example, to the add provider, we say that we require the lib module because we use a class from it, and that we provide a service with our add provider. The same thing we do for the sub provider. Is exactly the same thing. And let's see the lib module info for lib. Just export this package because we use a class from this package in different modules, so we need to export it. And finally, the runner requires lib and utils. And let's see the utils. It requires the lib. Okay, now. Let's try to compile it. I'm gonna compile. Okay, an error.
Oh.
Package exists in another module. Now the IDE will tell us that package org-enzo-lib exists in another module. So remember that I will just run the utils and lib. So they have the same package with the same name. And the reason for that is because this class, this utils, uses a package private method from a class in the same package. So inside the lib module, we have org-enzo-lib package, and inside the utils module, we have org-enzo-lib package. The module system does not like it. In a fat jar, this is perfectly okay. It is perfectly okay to have two different jars that contain a package with the same name, with either the same classes or different classes. And when you are loading the classes, you just pick the first one from the class path. That's okay. But with the modules, you cannot do that. You cannot have two modules with the same package name. It is called split packages. On Stack Overflow, you will most likely find a lot of problems with that, because this is the first problem that you will bump into. It's typical, for example, for unit testing. If you want to unit test some package-protected stuff, you need to declare the unit test in a separate module, but inside the same package, so that you can access the package private stuff. Okay, how to fix this problem?
I know. Let's do git checkout.
Let's do git checkout, yes. Let's do git checkout, yes, okay. Clean. Let's do git checkout solution, yes. I wish it would be that easy to do it in this way. Okay. Okay, so the fix, it's easier to see on the picture. We just move all the classes inside that one package into either a new module or into like one existing module, but we put it all inside one module. This is very easy on the picture and very easy set, but it's actually pretty difficult to do.
Oh, yeah. So originally we estimated that the upgrade to Truffle Unchained will take something like 2 weeks, and it was almost 2 months.
I think 3 months maybe at the end. And it was not only me working on that, but at the end there were more people involved. And it was a really very painful experience.
But that makes you the expert.
Okay, so now we have moved, we got rid of the utils module, and we moved the util class inside the utils module. And that's basically what we did, everything that we did. And let's try to build all the modules, install. Hopefully everything works. Okay, it works, nice. Now we have all the modules inside runner, target, modules. So we can see that we have 4 modules as expected. We can see that they are modules because they have the module info.class inside them. And so let's try to run the application by just putting everything on the module path and specifying the main module and main class. Yeah. Okay, the same output as before, okay. Before we had one fat jar that contained all the classes, but now we have 4 jars that are modular. I would also like to mention that there is, with the module system introduction, one of the advantages of it being built into the JVM is that there are now some very useful command line options to all the tools like jar and Java that allows you to somehow work with the modules. So for example, there is this -- describe module for the jar command. And if we want to describe, for example, this runner, it tells us that this is a module, tells us that Java base mandated, every module is implicitly dependent on Java base. Yes. You don't have to specify that, it's dependent, and that it requires sleep. This is what we have specified here, okay? Mm-hmm. Nice and useful. Another command line tool is list modules. Java puts some module path and then list all the modules. When we do that, the first thing that we will see is all the modules that are in the JDK release This is because I use the GraalVM JDK, so these modules are built into that release. Java-based and Java compiler, and all of that is just part of just the standard JDK, the JDK release. And then we have these 4 modules. These are our modules that we provided. Nice and easy. Okay, so
it's so beautiful to live in modular world.
yes. Okay, so we have solved that problem. There is another solution to the split.
It's not a
split
solution,
package.
it's a hack, right? Don't call
Note
it
that
solution.
the big picture with the hacker, you should be afraid of this solution because you can now specify both module path and class path to the JVM, and everything should just work. So to be able to, for the backward compatibility, there are some command line options that are now only in the hotspot JVM. For example, the patch modules that allows you to add some classes to a different module. So this kind of tells the module system that the lib module will also include a different class in some different, on a different file system path.
I believe this was introduced especially because of unit testing.
Yes.
Because this is what if you want your unit tests to access package private methods of your classes, then this is basically the option that you can use to achieve that. I would not recommend to use this option in production.
Maven automatically uses it for the command line option. And just one interesting thing is that I have tried to run our benchmarks with the patch modules option, and I have discovered that it actually has some impact on the runtime performance. I don't really have the hard data with me, but I just know that it is not a good idea to do it for benchmarking.
Oh yeah, Pavel was looking for a regression in our benchmarks, and at the end it was the patch module option.
Something that you have probably heard about now, because of the backward compatibility, we actually have 3 types of modules: an explicit, automatic, and unnamed. It depends on whether the jar archive has the module info inside it, and whether it is put on a module path or on a class path. So an explicit module has module info and was put on a module path. Automatic module, this is an interesting thing. This is like a plain jar without module info that was put on a module path. Automatic means that the JVM inferred the module descriptor for it. So it inferred the name. Usually it is based on the name of the jar file. It inferred all its dependencies somehow by some magic. It inferred all the services that it uses by some really magic, yes, and so on. So these are automatic modules. If you just put like your fat jar, for example, on module path, it will be an automatic module. And everything that is on a class path is an unnamed module. A technical detail is that there are actually more than one unnamed module, but that is just like a detail that.
So basically you can take your module jar file and put it on class path, and it becomes just a regular jar.
Yes, if you put your modular jar, exactly. If you put it on the class path, the module info.class is just ignored. And it's the same as if you would delete the module info from the archive and just put it on a class path. We are running out of time. We have so many
but we
slides,
don't have questions, so we can continue, but we need to speed up. So this is a slide with all those intrinsic command line options, right? Like add opens, exports, and limit modules. Oh, that's my favorite.
So for libraries, we cannot hack their sources.
Yeah, if you are using third-party library.
Yeah, and there are still many libraries that are not really aware of modules, and that, for example, the Apache Arrow is a library that tries to open for a reflection some class from Java and I/O. And nowadays,
Byte buffer, I think. It
byte
needs
buffer,
byte
yes.
buffer constructor.
And it used to be the case in JDK 11 that this would only give you a warning, but it would succeed. But in JDK 17 and JDK 21, this is an illegal access error. So if you are using this library on a newer JDK, you have a big problem because it will fail with the illegal access error.
This basically explains the main motivation for introducing the module system, or one of the main motivation that was increased security. So modules give you the encapsulation, and now the JDK is enforcing it more and more and more.
Exactly.
And as a result of that, more and more of third-party libraries stopped working. Or would stop without these magic options.
Yes, so for example, there is this magic option that allows you to specify that the Java and I/O package inside Java base module should open their classes for reflection to all unnamed modules.
Coming from the class path, basically.
That are in the class path, yes. So this will basically allow the Apache arrow to reflect on the byte buffer that is inside the Java and I/O, and everything will just work.
Hopefully, they will rewrite the library to not need this option in the future. The APIs are coming to the JDK, so chances are.
Yeah. Another example is Google Java formatter that uses the JDK compiler module, that uses some like internal packages from it. And to kind of fix that, you need to artificially add an export of some like internal package of JDK compiler module to all unnamed modules. By the way, you don't have to specify all unnamed. You can put either the Google Java formatter or Apache arrow jar archives on module path, which would make it an automatic module. If you know what the name of that automatic module is going to be, you can replace this all unnamed with the name of just that automatic module. So you just open the Java and I/O for reflection to the automatic module that contains Apache arrow only, which is always a good idea. But when JVM infers the name of an automatic module, it's kind of a magic. And if you have two jar archives that have the same name, you have pretty much no way of knowing what the automatic module name is going to be. You can modify that behavior with an attribute in manifest. The attribute is called automatic module name. So if you have in your meta-inf manifest, if you have this attribute, the JVM is going to specify that name of the module for you.
Yeah, I can see the suffering Pavel had when solving all these issues. Yeah, we are. So if you have questions, you have last 2 minutes to ask. We will go through the slides to reach some summary. Another problem that Pavel had to face was tools that were not aware of JDK, of the modularized JDK. One of the examples is Scala. Basically, Scala ecosystem stopped in JDK 8, and they just decided to ignore whatever happened after that. So Pavel had to write our own SBT build plugin. But Maven and Gradle should be way better.
Maven is okay. The latest example we have seen in the Maven, if there is module info in your Maven sources, it is going to put that module on module path automatically. But SBT does not do that. You have to somehow do that on your own.
So another
we
issue
have talked about the testing and benchmarking slightly. You need to also
patch modules is your friend in this case, and it does not matter. It's not a production, so unit testing is fine. And yeah, basically, we might conclude with this slide and describe how great future is ahead of Enzo, right?
Yeah, we should. By the way, there is no versioning in module info. This is the Java module system deliberately does not introduce any kind of versioning because, as the author says, the versions are handled by the build tools.
Yeah,
I would like to just conclude in the slide.
Yeah?
What are the
Benefits of
benefits?
modularity is a good conclusion, indeed. Encapsulation is perfect. It gives you friend packages, so that's great. The registration and discovery of services built into the module system is really an essential thing, a kind of replacement of dependency injection in the modular world, so that's really great. One thing we have not really talked about is using utility called JLink, which allows you to take your JDK and only specify which modules you want to use. So if you want a JDK without Java Desktop, you can do it with JLink. And Enzo is actually like using these kind of smaller JDKs. What's the last one?
I have shown the command line tools. There are some built-in command line tools now that are pretty useful when you are working with the modules.
Well, I guess we covered most of the obstacles or problems you can face when you decide to go to use modularity. But at the end, I would say Enzo benefits from switching to the Java platform modularity. So I wish you will benefit as well.
Yes.
With that, thank you
There
for your
are some
attention, and you can
references, yes.
find us around and talk with us if you have more questions.
Thank you very much.